In the last video, I told you that the answer to number 17 was 0. Let's go ahead and do that. So on the right-hand side, 3 times 4x is 12x, and 3 times 1 is 3. But then I've got to subtract this 1 because they're like terms. So 3 minus 1 is 2. So we've got 12x plus 2. On the right side, we have 2 plus 9x. All right, so we got to focus on those x's. You may even notice at this point in time that the only answer that would possibly work would be 0, but let's just keep following our procedures. So we subtract 9x from both sides, and on the right side, 12x minus 9x is 3x, and then I've got the plus 2. Bring my 2 down here. I don't know if you've noticed, but I'm very vertical and very direct about bringing down my equal signs, bringing down my terms right below where they originally were written. Remember, I'm trying to get x alone, so I've got a plus 2 over here, so I've got to subtract 2 from both sides. So, oh, that's weird. I get 0 on the left and 3x on the right. But I can divide 0 by 3. It's not a problem at all. I just can't take 3 divided by 0. 0 divided by 3 is 0, and there's my solution for x. Now look at number 18. On the left side, you have like terms that have to be put together first because they're on the left side of this equal sign. So 7x take away 3x is 4x, and then you've got that minus 2. And then on the right side you have 4x. Would you pause here for just a minute and say to yourself, how could I ever take 4 times some number and subtract 2, but then take 4 times some number and that's it, and get a true statement? I just can't do it. Now, oh well, let's say I can't figure that out, so I'm going to subtract 4x from both sides, trying to get the x's on one side. And 4x, take away 4x, is nothing x. 0x doesn't exist. You could even put a 0 here if you want, or I'm sorry, a 0x. But essentially, not necessary. What happens here is that when you get a statement that is not true, negative 2 does not equal 0, and you've lost all your x's, we have what's called a contradiction, or it just has no solution to this algebraic equation. Okay, let's do some more. Again, you can pause my video and work on these problems on your own just to see how you're doing. So a lot of parentheses here. Be careful. Don't take 9 minus 3 and get 6. You're going to have to distribute this minus 3 times this minus 2x, and this minus 3 times that minus 4. So let's copy this 2 down. Again, I'm being very deliberate and trying to bring everything down right below. So this essentially negative 3 times a negative 2 is a positive 6x, and negative 3 times a negative 4 is a positive 12. And I have gotten rid of, as a result, I got rid of that set of grouping symbols. I think before I go on, I'm going to take the 9 and the 12 and add them together inside those parentheses. So I'm just going to clean up the left side. So I've got a 6x, and then the 9 and the 12 add to be 21. And so let's keep going. 2 times 6x is 12x, and 2 times 21 is 42. Let's bring down the right side of the equation. Hey, wait a minute. The right side is the left side. They're exactly the same. So you could go about trying to solve this. You know, you could go ahead and subtract 12x from both sides, but you lose all the x's. And what you have is 42 equals 42. If you get a true statement and you lose the variables, then you have many solutions to this problem. It's called an identity. The left side is just like the right side, or they are identical. So many solutions is all you need to tell me. Next, when doing a problem with some decimals, I would advocate, because you're using a calculator, just take your calculator and take 0.2 times 3 in case you're going to make a mistake with the decimals. That's 0.6x. And 0.2 times a minus 4 is a minus 0.8. Again here, but careful, this is negative, so that's a negative 0.6. And this negative times a negative is a positive 0.8x, and bring down the 0.7. On the right-hand side, I've got some like terms. They're just numbers. A negative 0.6 and a positive 0.7 is 0.1. Then I have that 0.8x there. And now I'm going to go ahead and get my x's on one side and my constants on the other. Now I do want you to know, if you wanted to right now, this is the time when it'd be the easiest, is you could multiply the whole thing by 10. Or in other words, move this decimal, move that decimal, move that decimal, move that decimal, and call this 6x minus 8 equals 1 plus 8x. A lot easier to look at. So now I'll subtract 6x from both sides in order to get the x's on the right. That's where I prefer to put it in this case. And then I'm going to subtract 1, because this, what in front of this 1 is a plus sign. It's just not written. I'll subtract 1. So I'm adding two negative numbers over here. They combine to be a negative 9. And then now I've got to divide both sides by 2 finally at the very end to get x is equal to a negative 9 halves, or you can say negative 4.5, or for checking with your calculator, you could just use a negative 4.5. Okay, this absolute value equation, challenging, interesting, kind of fun. What we first have to do is get that variable alone. So we'll add 7 to both sides, and we'll have the absolute value of x is equal to the number 11, 4 plus 7. Well, let's see. What could x be? Could it be 11? Can you put an 11 inside there, and is the absolute value of 11 equal to 11? Yes. So x could equal a positive 11. But could x be a negative 11? So could you put inside of that bracket a negative 11, and would you still have a true statement? So what's the absolute value of a negative 11? It's 11. And you have another true statement, yes. So x can be both 11 and a negative 11 in this problem. Pretty interesting. All right, the next few problems are proportions. And so I would like to advocate when solving these proportions, it says solve ratios. Boy, that's a typo there. That really should say let's solve these proportions, because a proportion is two fractions set equal to one another. So come on over here for a minute. 2 over 4, that's a fraction. 1/2, that's a fraction. And we all know that that's a true statement. 2/4 reduces to 1/2. But the big thing, I want you to know that this product, 2 times 2, which is 4, will equal this product, 4 times 1. So when you set the cross products equal, it's real easy to solve an equation. So I'm suggesting here that you take 7 times r and set it equal to 3 times 42, which is 126. And then we would divide both sides by 7 to get r alone. And so we'd have r is equal to 18. Go back to the original problem. 3 over 7. I'm just dropping the decimal places for now. We won't talk about rounding in significant digits. Yes, I know that in this problem, most people would say that you would multiply both sides by 42 to get this r alone, because the 42's in the denominator, those will cancel out. So surely you can go ahead and do it that way as well. You would take 42 times 3 here and then divide it by 7. Well, that's what we did. We took 42 times 3, got 126. And then we divided it by 7. It becomes particularly nice in a problem like number 23. So if I just set those cross products equal to one another, I'll have this 33.7x times the 38.4. And then I'll set that equal to this 47.5 times 1,289. And it looks like these two numbers multiply together to be 1,294.08x. And then this other side is 61,227.5. And then just go ahead and divide by the 1294.08. And when you do that division with your calculator, you'll get x is equal to 47.3. I rounded it to 3 sig digs, and that's because my least number of significant digits was the 38.4, the 47.5, the 33.7. So 3 significant digits. Let me just tell you that this one, the answer is 3.93 volts. When you go ahead and distribute this times this, and this negative times this negative is a positive, I'll go ahead and start some of it, but I'm not going to finish it. Let's see here, I think this is 7.035, and then you'd have a positive 0.67 V. And then equals 0. So be sure to combine both terms. They look to be 1.79 V. And then I'm going to throw, or I sometimes will say to you, let's throw this 7.035 to the right hand side. And then now you'll divide by that 1.79 and find out that the voltage is 3.9 volts. I'm going to try to squeeze this last one in and hope you aren't getting too much at one time. Read this at your leisure, but I'm just going to set up the proportion. It says that a person who is photographed is 1.8 meters. That is their height. And the film image of that person is 20 millimeters in size. So if we were under the same conditions, what I want to know is how tall is a person. So I want to know their height. So over here I'm going to put an X in setting up a proportion, because this relationship should be the same under the same conditions. If the film image is 16 millimeters, so would you notice that here I had 20 millimeters, here I have 16 millimeters. So those units are both in the denominator. Upstairs I have a height of 1.8 meters, so I want to find a height over here. And so I'm now going to set the cross products equal to one another. So I like to put the 20 times x on the left and the 1.8 times 16 on the right. And when you solve this for x, you're going to find out that the person is 1.44 meters in height.